Hi friends, Assalamu alaikum. Another video regarding this machine foundations. We come across, especially in the industrial buildings, we need to have, we need to plan for different type of machines, their stands. Some of the machines, some of the machines, we need to plan different type of, equipments. On sometimes on the floor, sometimes on, on the typical floors, and even sometimes on the roofs. So, what are the type of the machines and what type of analysis you have to do, that we will discuss in this video. Okay, so let us discuss what type of machines are there. So there are three type of machines. We have reciprocating machines, impact machines, rotating machines. Okay, uh, see in reciprocating machines, where you have generally frequencies will be less than 600 rpm, and for examples for the reciprocating machines are compressors, reciprocating engines, and sometimes, especially reciprocating machine, this the engine of a train, where you have this action of a piston, and impact impact type of machines, where you have huge, sometimes we have done one machine which is almost having 3000 tons of the load, impact load, especially for making this molds. We use this type of machines and rotating machines. So more, especially in the rotating machines, we have this more RPM, 3000 to 10,000 RPM. And examples for these rotating machines are turbo generators and rotary compressors. Now, for the static load parameters, sometimes this machine loadings are static. Don't have, especially for the machines which don't have much RPM, like this reciprocating machines, even, and impact machines also. Only impact machines also, they won't be having that much frequency, because they have the thrust, they have the impact, but the RPM of the machine is not be much. Especially RPM of the machine you have to consider for the rotating machines. So for the static load, where your RPM values are not much, on a higher scale, so you have to see that there's no shear, bearing capacity failure, and even no excessive settlement in the foundation of the machine. And whereas, if you consider this dynamic load analysis, the parameters which need to be checked are, you have to consider this, there is not a, we don't have any resonance. Resonance is, I think, most of the people, they understand what the resonance is. For example, when a flock of the army is moving on a bridge, and they are moving, making a march on the building, on the bridge, and due to that march, what they are doing, the frequency of the, of their march, if it is, if it is matches with this frequency of the bridge, then resonance will occur. This resonance, an experiment we used to do when we were on, 10 plus 2 tuning fork, where you make this small paper chips, and when you keep on the table, and when you give certain frequency to the tuning fork, and when you touch this with this table, these flocks will fly in the air, because generally paper slips are very small in, weight, and due to this frequency, the resonance occurs, and then these papers, they blown up in the air. So similar concept will happen, especially for the structures, where your operating frequency, if it is matches with the natural frequency of the structure. And another thing which you need to consider is the amplitude. You know, the amplitude of the foundation should not exceed the permissible limit. And even, the vibration of the machine should not be, should be in a permissible limit, especially for the human ear. where we will be discussing charts, where which will give you us the idea of these vibrations. So for the method of analysis for the machine foundations, you have two method of analysis. One is mass spring dashpot model, and another is elastic half space model. And this EHS theory, it based on the linear theory of elasticity, where your stress strain curve will be on the linear part of the of the curve. And theory of the reduced natural frequency method was also there. We have a semi-empirical method, to use to find the frequency, of the foundation. And especially for these medicine foundations, when you talk about the type of the medicine foundations, we have three types. One is block type, another is box or caisson type, and the third one is wall or frame type foundation. So individually, when we see this, how this block type of foundation looks like, see, you have this solid block, which consists of your motor and machine. And here sometimes, machines, and for the motors we need to find the RPMs, and we should not coming in the dynamic response range. Okay. And pedestals, here we need to check for the six type of freedom, yani, six type of motions. When you see the next image, because we have these three type of translation directions, three type of displacement in x, y, z directions, and the three types of rotations in x direction, in y direction, in z direction. So totally six type of displacements can occur for any block which is subjected to the machine load. So next is the box or caisson type. Especially this type of foundations are adapted in hydraulic environment, especially where you need to install your machines under the water. So there this type of foundations are used. For this type of foundations, where you have caisson, it is embedded in the soil or in water. There then you will do your concreting, and after this settling of this concrete, then again you will transfer the loads on the foundations. Next is wall or frame type. See, first of all is the block type, and next is box or caisson type, and the third one is wall type foundations. These are the six type of degree of freedom, six modes or degree of freedom, which I was discussing before. So you can have different names for that. One is a torsion, and another is about the x-axis you have pitching, and about the y-axis it's called rocking. So these six directions, this block can move. So any one of them or the combination of the forces, you should need to consider that it is acting on the foundation system. So when you coming to the criteria, for especially for to be considered for machine design, you have one is dimensional criteria, another is vibrational criteria, third is displacement criteria. And dimensional criteria is sometimes you need to check it is in sliding and overturning whether it is okay or not. And another is vibration criteria, that the vibrations which are generated by this machine is within the range, what we can hear to a normal human ears. And especially displacement criteria, where your machine, when it is in the working, you should keep a close eye on it, whether it's yani, whether it's earning and whether the displacement are within the permissible limits. So for the dimensional criteria, what you need to check area of the block, okay, any, because when you consider the plan of the machine foundation, you should see any utilities are not colliding with it, you are not having any headaches from the from the other departments. So first of all, you have to decide the area of the block, then the size of the foundation. It should be more than the base plate, okay, base plate which is resting the machine on the foundation. And foundation block should be placed deep enough on a any good bearing strata. Combined center of gravity of the machine plus foundation should be as far below the top of the foundation as well, because when the machine and when your motor, if their center of gravity, yani the center of gravity is much away from the center of gravity of the foundation, then due to this eccentricity, extra moments yani will come on the machine. And that's why eccentricity what you are giving, that it should not exceed 5% of the least width or horizontal dimension. So now the last but not the least is vibration should not create rotational vibration. Should not create rotational vibration. So see, when considering the vibration criteria, there are two types of yani foundations. One are undertuned, where you are the frequency of the machine foundation, the ratio of that divided by the frequency of natural frequency. If it is less than 0.5, that for important machine. And in the overturned yani condition, there are the frequency, the ratio of the frequency of this of the machine with the natural yani angular frequency. If it is more than 2, it should be in the overturned foundations, whereas in the tuned foundations, it is 0.5. So Richard's chart, where you have to consider this permissible displacement of the machine foundation system, it should be less than 0.2 mm. And also for various modes of vibration, vertical modes of vibration, you have to consider this Richard's charts. Okay, that's it, dear friends. This is yani I was thinking that I can give some introductory lecture on the machine foundations. Inshallah, in the future we will go on separately on each and every foundation, how to analyze it, how to see this amplitudes, how to check it for the stability purposes. Till then, assalamu alaikum. Stay blessed. Eid Mubarak all.